All right, let's look at number 7 on the review. It says the fees charged by Wendy's Super Tutoring Service is listed in the table. Is the data linear? First off, what does linear mean? It means that it's a straight line. That's right there in the word linear. Okay, so in a table though, see we don't have this as a graph, so in a table, how do you know when it's linear? In a table, it's going to be when delta y over delta x is the same. So now I need to go over here and I need to find delta y and delta x. So here, delta y, the change in y right here. Now, if you don't know how it's increasing, take the bottom number minus the top number. But that's going to be plus 21. The next one, how do I get from 119.95 to 140.95? Plus, is it 21? All right, delta x. Now, this does not mean that it is linear. Not this alone. You have to do delta x. I have plus 2 and plus 2. Now, when I take delta y divided by delta x, I get 21 divided by 2. It is 10.5. This right here is my coefficient. It is my rate of change. First off, since it's the same, yes, it is linear. If you know it's linear, then you can find the equation. Okay? Let's talk for a minute. What does this 10.5 is the coefficient? What does that mean? It's what it's increasing by, right? Like what's being multiplied by the x. But in this word problem, what does it mean? Now, one thing, I think I heard somebody starting to say it. It is going to be the cost per hour. Now, look, on the coefficient, if you'll make yourself a note, y per x. If you look at the x and y, in the y, it says cost. So it's the cost per hour. That's the charge that they're getting for tutoring. You need to remember that your equations should be y equals the coefficient times x plus or minus the constant. Now that's not just what we have to find the numbers. See, like right here, I know that my equation so far starts off as y equals 10.5x, but I don't know what else it is. So what I have to do is I have to go over here and make my table a little bit bigger and put my numbers in there. I have 10 and 98.95, 12, 119.95. Your coefficient goes first, which is 10.5. Then I multiply it by my x, which is 10. Oh, I forgot to do this one. 10.5 times 12. When you multiply these two numbers, 10.5 times 10, what do you get? You get 105. What do you have to add or subtract to that number to get 98.95? So what you need to do is you can go in your handy dandy calculator. I've got to pull mine back up again. Okay, so what I'd asked you to do at first was to take 10.5 times 10. And you got 105. We have to take, if I took 105 minus, well, actually, I should do it the other way, but I'll just do 9. Well, let's do it this way. Take this number right here, 98.95, minus 105. This is your rate of change. This is what goes right here, minus 6.05. So my constant is 6.05. Now, it says to give a description in words. First off, we just said that the 1050 is what they charge each hour. What in the heck could this minus 605 be? If you're going for tutoring and they're charging $10.50 an hour, what could, when you're talking about paying for something, what could it be when you're subtracting something off? A discount, a coupon, right? So you could say, Kyla goes to tutoring for $10.50 per hour, but had a coupon for $6.05 off the bill. Now I could say anything you wanted. That was just happened to be something I came up with. You have to be able to try and write the situation to match the equation. On the next one, it says the graph represents water draining from a bathtub. Is this data continuous or discrete? How do you know it's continuous? It's constantly going down, but how can you tell in the graph? It's just a straight line. There's no dots. On a graph, discrete is going to be dots. Now, the domain, remember the domain is my x. So on your paper, I would label x and I would label domain. What does the x number start at? It starts at 0. And where does my data end? Nah, the graph ends at 5. My data ends at 4. That's one of the biggest mistakes. People try and tell me it goes all the way out till 5. The data, it goes from 0 to 4. So the way we write this, it is continuous. So you put the small number at the front, larger number in the back, and the x is in the middle. It's in between. Your arrows are always pointing to the less than. And because it equals the number it started and ended with, you add the equal to bar. Now the range goes up and down. So here's the y for the range. The range it starts up here at, what is that? I can't tell on mine. I colored it in. 24. And it goes all the way down to what? 0, because it empties out. Now, some people get confused trying to write this because they think they start at 24 and go down to 0. Always start with your smaller number over here. So the smaller number is 0. The larger number is 24. The range has the y in it. It is less than or equal to, and that's your range. To have the line on it is if it equals that number. The only time it doesn't have the equal to is if you have an open circle. Something like this. Where this one is equal to, this is not equal to, and this one is equal to. They're both dots. It starts at 24 and ends at 0, so it's equal to. Which of the following is true? Water is draining at 4 gallons per minute. After 3 minutes, there is 8 gallons left. And okay, so what I would do here is let's start process of elimination. It says after 3 minutes, there's 8 gallons left. So if I go over here to 3 minutes, and I go up here to 8, is that point right there, is that on the line? No, 3 and 8 is not there. So B is not it. It's that after 1 minute, there's 20 gallons. So I go to 1 minute, and I'm going to go up to 20 gallons. That point is not on the line. Well, now I've got to figure out, is it draining at 6 gallons per minute or 4 gallons per minute? It's asking you to find the rate of change. You have to find points and figure out how many down and how many over. Now, on this graph, I could start here and do it like this. Watch, I have my y-intercept and my x-intercept. I go down 24, that's my change in y, and over to 4. This is delta y, this is delta x. If I had made a table, let me move this up, it would be 0 and 24 and 4 and 0. This would have been minus 24. This would have been plus 4. Now, the reason why it's a minus is because it's going down. Now, negative 24 divided by 4 is what? Negative 6. This negative just means it's draining. It's draining out at a rate of 6 gallons per minute. So your answer should have been D. Let's look at problem number 9. On number 9, it says complete the process table and write the rule for, and it gives us in words right here. It says the y value is 2 less than 3 times the x value. Take a minute right now and try and write your equation. Put it up. Okay, on this one, it says the y value is means equals. Now, 2 less than, this is tricky right here. One of the biggest mistakes is people do this. 3 times the x value. I'm telling you that this is wrong. Okay, I wouldn't write that. That's wrong. But it's a mistake. The reason why is because when you write this, it's y equals. When you have less than, that 2 has to go at the end. So it's 3 times the x value less than, and you take the 2. So when you say, let me go over this again. When you see the phrase less than, that number right here has to go after. That's why it's at the end. So my rule would be 3x minus 2. The equation, there's a difference between it. The equation is y equals 3x minus 2. It wanted you to fill in the table. So you can put that in your handy dandy calculator and I can fill it out. So I'll go up here and go to y equals and put in there 3x minus 2, second graph, 0 and negative 2. So y right here is negative 2. Then I have 1 and 1 and 2 and 4. That's what you should have done by filling in your table. On the worksheet that we have, flip your paper and, flip your paper and you need to go and do number 10, please. Right now, there's number 10. Okay, on this next one, they're just giving you some blanks, or they're giving you some answers up there, or some words that you can use for some of these blanks to help you. It says Mrs. Wadsworth is plans to bring cupcakes to her favorite class. She will buy 2 cupcakes per student, C, plus 10 extra cupcakes for the other algebra teachers. The function that represents this situation is y equals 2c plus 10. First off, y is the what? Y should be the dependent. That is a dependent variable. And what does it represent? What are the 2 things we're talking about? We're talking about the number of students And what do each one of what do the students get? Cupcakes. So the y is the number of cupcakes that they get. So the dependent variable is the cupcakes. That's the end result. Now C is in the X spot right here. C is the independent variable. C represents the number of students. Now 10, the number 10 right here is a one-time thing. You're only adding it on one time. That is your constant. In the problem, it says it is the 10 extra cupcakes. So it represents the extra cupcakes. Now the 2, it says up here in the problem, 2 cupcakes per student. That is your coefficient. It is also called your rate of change. And what does it represent? It represents the number of cupcakes per student. Number of cupcakes per student. Because that 2 is how many each student is getting. Number 11. All right. You should know this, and I've stressed this, you have to know it. When I ask you what is the linear parent function, what is that equation? Y equals X. If you don't know that, you're not going to pass. Linear parent function, Y equals X. It says list some characteristics. Well, it goes through 0, 0. Okay, it always goes through 0, 0. It's going to be an increasing line. And the X and Y numbers are the same. So if I go over here and go in my calculator to help me, and go to Y equals and put in there Y equals X and press graph, I should be able to see my line. So as I go to make my line, oh, where'd it go? It increases up 1 and over 1 the whole way up. Listing some of my points, again, 0, 0, 1, 1. I could have -2, -2. The X numbers equal the Y numbers. You have to know this. You have to know that the linear parent function is Y equals X. The next thing says determine if the following relationship is a linear relationship. Where's my screen here? There we go. So the first one, does it make a line or not? That's what linear means. Some people get this confused with if it's a function. If I asked you if this information was a function, what do you look for? Yeah, if it's a function, the X numbers cannot repeat. That's what we did before. And in this case, it's 22, 30, and 46. Okay, great, it's a function. But that's not what it's asking. It's asking, is it linear? So to be able to find this out, when it has ordered pairs, you have to make a table. Because the only way you're going to know, maybe make it smaller here. The only way you're going to know is if delta y over delta x is the same. So I have 22 and 11, 30 and 15, 46 and 23. So I have to do delta y, the change in y, plus 4. Right here, what is that, plus 8? So then delta x plus 8 plus 16. I have to take delta y divided by delta x. 4 divided by 8. Now let me show you something. If you go in your calculator and put in there, in the home screen, 4 divided by 8, you could do it this way and you'd get a decimal. Then do 8 divided by 16. Decimal. It's showing you that they are the same. If they are the same, then that means that this is linear. Whoop, I didn't mean to move you. Here we go. It is linear. But what I want to show you in the calculator is if you want to make it a fraction, right here, once you get your decimal, if you press math, enter, enter, it changes it. It reduces any fraction. It doesn't matter what you do. Like if I did 10 divided by 150, and I press math, enter, enter, it will reduce my fraction for me. Okay? So that's something that can help you. The second one says, is this linear or not? It says the cost of a plumber is $30 an hour, and it has a service fee, a $25 service fee. The way you know it's linear, this is your rate of change. Does it say it goes up by different amounts? No, it only goes up by 30 since it increases. Since your rate of change is the same, if your rate of change is the same, then yes, it's linear. Because in that case, my equation is y equals 30x plus 25. Here's my next one. It says the cost of apples is $1.75 a pound. Okay, well, y equals $1.79 per pound. That's my equation. I could put it in the calculator and look at the line. But here's the thing. Every pound, it's the same amount, isn't it? If every pound it's the same amount, then yes, it is linear. As long as the rate of change, as long as it is increasing by the same amount. It just gives me an equation. You should remember that if the exponent is 1, that it is linear. But if not, I can go into the calculator, type in there 6x plus 2, and press graph. It makes a straight line. It is linear. The next one. Put that in the calculator, press graph. Actually, the next 3. Put that in the calculator and see if it's linear. On negative 4x, well, negative 4x, press graph. It makes a straight line. It is, oh, don't move. It is linear. The next one says x squared. If you remember, I said that anything that had an exponent on it, it wasn't going to be linear. This is going to make a curve. It's called a parabola. And with that, this one is nonlinear. The last one on this group right here on this page says 1/3 x. 1 divide 3 x, and I'm going to press graph. That makes a straight line. It is linear. So this one is linear. I think that's all on this slide. Okay. Now looking at these graphs, it's much easier to figure out if it's linear. Linear means line. Is H linear? Nope. What about I? What about J? Yes. These two are straight lines. This one is not. So when it says how can you tell if a relation is a function, Okay, so this says, how do you determine, this is what we talked about, can you tell if it's a function? It's a function if the x numbers do not repeat. That is totally different than if it is linear. Linear, when you tell if it's linear, linear just means that it makes a straight line. There is a difference between these two, and you need to make sure to keep them straight.